Thank you very much for this nice introduction. I'm sad that I cannot be in person in Washington, D.C., but some health reason prevented from flying. So I will tell you about our project SwissBritNet, which is exploring the Swiss-British relations in early modern times. And we will use a RDF-star-based knowledge graph. This work has mainly been done by Dr. Sepideh Alassi, who is a postdoc with me. Unfortunately, for some private reasons, she is not able to give the talk, so I jumped in to give the talk that you can hear about this project. It's a collaboration project between the Digital Humanities Lab and basically, and very important, the Department of Languages and Literature, especially the Anglophone Linguistics and Literary Studies of the University of Basel. And we are also collaborating with the HallerNet, which is a research infrastructure at the University of Bern. The project is being funded by the Swiss National Science Foundation. It runs about since a year, and we have another 3 years. So it's a very early stage that I will present you now. The SwissBritNet will investigate the Swiss-British relations in the 17th and 18th century. There has been a lot of interaction between Switzerland and Great Britain on the basis of religion, on the basis of politics, and certainly on the basis of science. The University of Basel, of course, Basel is the home of the most famous mathematicians, Leonhard Euler and the Bernoulli dynasty, and both Leonhard Euler and the Bernoullis had a very close relationship to Great Britain, Newton, and so on. Now, first, let's talk a little bit about the resource description framework, which is the technical base of linked open data. And linked open data is something that's very attractive in humanities to record data. And in fact, linked open data and the RDF framework is very, very simple. All the information is reduced to simple statements. So everything in an RDF database is a statement. You have a subject, you have a predicate or verb, and you have an object. So let's look at an example. Mozart is the composer of the Magic Flute. Mozart is the subject, we have the predicate, composer of, and we have the object Magic Flute, which in this case is a literal value. Mozart has a birth date, and the last triple, because these are always 3 parts in such a statement, Mozart is acquainted with Salieri. There, the object again is a subject. This leads to something we call a directed knowledge graph. Now, this looks very complicated here. The reason is that for putting this into the computer, both the subjects and the predicates have to be encoded as ARIs. This makes the things a little bit complicated, but we will shorten it up. And with this, you can create very large graphs representing your knowledge about the topic. In our case, the SwissBritNet. Now, one thing which is very important is that we need to do statement about statements. So we want, for example, say the famous director Milos Forman says Salieri killed Mozart. So that's a statement about a statement. And here lies a big problem with RDF, with the resource description framework, that this kind of statements about statements is very complicated. You have to go to the so-called reification statements, as I noted here an example. So Salieri killed Mozart, that's the statement. And then we need to add a new resource, an assertion resource, and use at least 5 statements to say Milos Forman says Salieri killed Mozart. So that's not a good way. Fortunately, there has been in the last years a new development which extends the standard of RDF, and it's called RDF-star. It's not yet fully adopted by the World Wide Web Consortium, but the draft is finished, and I think in the next few years it will be an official World Wide Web standard. And most of the big players in RDF databases are already supporting this proposed standard. So, for example, the open source Jena Fuseki framework supports it, but also commercial triple stores do support this kind of simplification. In order to express Milos Forman beliefs Salieri killed Mozart, we can add this statement here, Forman beliefs, and then with this special notation, we can add the statement that Forman believes. Graphically, this looks like in this slide. So that is much, much simpler than the reification statements. Using this notation, and it's very easy to query about these things. So, for example, the question, what does Forman believe? Is with this simple Sparkle query, 3 lines, select belief where Forman believes, the belief, and then we get what Forman believes. We can also ask, who killed Salieri according to Forman? And we get the answer. So this is really a simplification. In our project, where we address this relationship between Switzerland and Great Britain, we do not know yet which questions will be asked to the data. So it's very important to have a very simple and flexible system, because the research questions at the end can be very, very different, and we do not know about it. So our system we want to build has to reflect this flexibility. Of course, if we have these possibilities, we can add more statements about the statement. So for example, here I have Forman believes Salieri killed Mozart, but I believe an illness killed Mozart. And we can query in this case also with a quite simple Sparkle statement, who believes what? So that's really a very simple thing. In a master thesis, we made a test project. We created the digital edition of Jacob Bernoulli's Reisebüchlein, a travel journey log. And we created an ontology and implemented this with quite a lot of data to see if it works. And it's very interesting that we can really pose very crazy questions at this data and get good answers. In order to do this, Sepideh Alassi also developed a machine learning pipeline to extract named entities. This pipeline, by the way, is open source, so you will find it on GitHub. It's implemented using Python, and it will use the text and the ontology of your project and create automatically the knowledge graph out of this data. I think that's a very interesting thing. And Sepideh also tried foreign languages and foreign writing systems, so she also implemented Farsi because that's her mother tongue. In relation to the SwissBritNet, we are also interested in travel writings. There are a lot of description of travels between Switzerland and Great Britain and within Great Britain and within Switzerland. For example, Thomas Platter, a famous man from Basel who was a early medicine doctor and was also professor at the University of Basel in these early times. Thomas Corriet, Kaspar Vasa, and so on. And we are looking at these data. Now, the collaboration with the HaloNet for us is very important. Sorry, how many minutes?
You're at the 10-minute mark already.
Okay, so let's go. The infrastructure will be between the HaloNet, which is a PA XML-based thing, and our Sparkle network. We will integrate these two things. We will add network visualization. That's something that's very nice, that you can do 3D visualizations. And that's the end. If you are interested in more, you can look at this QR code, go to the website of the SwissBritNet.ch. Thank you very much.